Welcome, everyone. My name is Vladimir Agaev, known on the internet as Vlad Wulf, and I'm a blockchain developer. So I have some slides here. Okay, so this webinar is about smart contracts 101. So my name is Vladimir Agaev. I have a background in law and computer science. I'm a web and blockchain developer and also a blockchain instructor. I have worked for big corporations like banks and big supply chain corporations, and also for small startups. And you can find me on YouTube by typing Vlad Wulf, Twitter, or Facebook. So basically, in this webinar, we are going to talk about smart contracts. And here's a brief introduction to this concept. So what are smart contracts? The notion of smart contract was created by Nick Szabo in 1996, and in his vision, smart contracts were computer protocols that allow contractual relationship. So in his vision, smart contracts were smart because they were self-executing, and contracts because there was no problems of legal qualifications of those contracts. They were considered as contracts from the beginning. So the whole notion of smart contracts was reintroduced by Ethereum in 2013, when Vitalik Buterin actually have written the white paper. And in Ethereum, the notion of smart contracts is very different. And in fact, I don't even think they should call that smart contracts, but nevertheless, in Ethereum, smart contracts are not smart. They are not self-executing. You have to call them on the blockchain. You have to interact physically with them. And they are not contracts. They are just computer code. So there's no legal qualification that says, okay, a smart contract is a real contract with legally binding and stuff like that. It's just a script. So smart contracts have a certain architecture. It's basically a script, as I've already said, and a script that can be triggered by users. And this script lives on top of Ethereum blockchain and can change the blockchain state. So think of it like a application that is living in your phone, Android phone or iOS. Before Ethereum, blockchains usually used to be custom made. So you would usually fork the Bitcoin blockchain, modify it for your needs. If you need a certain derivative contract to be available on the blockchain, you modify the source code and it works. But if you want to change something, you need to remodify the source code and basically create a new blockchain. And this is a problem that Ethereum have resolved, because you can write those small little applications on top of the Ethereum protocol. And those applications are like small apps in your phone, and those are smart contracts. So that's why I don't really like the word smart contracts for this, because it's just a script. It's just a computer code. So smart contracts are executed in the EVM, which is the Ethereum virtual machine, which is another layer of abstraction that lives on top of the Ethereum protocol. And this EVM allows for smart contract execution directly on the blockchain. So it's like a closed, sandboxed environment that everyone has. So there's no problem of cheating, and the execution of the code in the smart contract can be deterministic. So that's why Ethereum has a EVM, but the code itself is stored on the blockchain. So once a user wants to execute a contract, he will call that. The EVM will execute the code that it will get from the blockchain, and it can change the blockchain state. Like if a contract wants to send a certain amount of Ether to an address, well, this action will be passed down to the blockchain. So yeah, EVM is a sandbox for contract execution. EVM reads assembly instructions and executes them on the blockchain. So people don't really like assembly. I mean, that's the reason why C was invented. And people don't want to write in assembly. It's a very tedious process. So that's why in Ethereum, we have higher level languages like Solidity, LLL, or Serpent. Solidity is the most common one and the most famous one. So if you are beginning, it's better to use Solidity. You will find most of the documentation on Solidity anyway. So yeah, again, languages like Solidity avoid writing in assembly. So they are compiled down to assembly so the EVM can read them. So we are here talking about Solidity because when people are talking about smart contracts, it's really about Solidity. And there are like main code components that every contract has. And those code components are the contract name. You can declare several structures like libraries or contracts in Solidity. So once you are declaring a contract, you have to write the keyword contract and pass the name of the contract, and you can write the execution code you want. So in the contract, you have the getters. Getters are functions that like get the information from the blockchain, send the information from the blockchain to the user. So they do not change the blockchain state. They cost no gas, and they are not bound to an account, so everyone can call them. If you have a blockchain and if you know the address where a certain contract lives, you can just call them even if you don't even have an account, because you don't pay gas, so there's no you don't need traceability on that. However, there are also setters. Setters are very important because they are basically what the smart contract does at its core. They fire transaction on the blockchain, so they modify the blockchain state. So they cost gas. Gas is a resource that you pay in Ether in order to perform computational operations on the EVM, on the Ethereum blockchain. And they cost gas, so you have to pay a transaction fee for them. They are bound to an account. That means that you can always know who called a function, who did what on every contract. And finally, you have the constructor. If you have already programmed a bit, you know what a constructor is, but basically a constructor is a function that will be fired on the contract creation. You can see the contract like an object, like a class. So when you create the contract on the blockchain, you instantiate a version of this contract on the blockchain, and this constructor is called, and it's basically a setter that is called once at the deployment of the contract. So, and yeah, there are also events. It's very difficult to keep track of the state of the execution of the smart contract on Ethereum. That's why we have events, and events are like function calls in the smart contract that create locks on the blockchain. Locks are like small locks, and you can actually listen for all those locks from, let's say, blocks X to blocks Y. Concerning a certain contract with a certain type of events, so something like update status. So you can listen what happened on your blockchain, but obviously you have to program the events in a way that allows you to do that. Solidity main functional components. So this is what Solidity can do. It's not a exhaustive list, but it is like the main list of what Solidity can do. So permissioning, you can say that, okay, a certain function can only be accessed by certain users. So it's permissioning. You also can interact from contract to contract. You can have a contract calling another contract, getting the information from that contract and updated its own state. You can also use oracles. It's the same as contract to contract, because let's say if you want to create a trading application on the blockchain, you'll need to get the price of a euro dollar, for instance, from somewhere, right? And this somewhere needs to be an oracle that will push the data on the blockchain via a smart contract, and other smart contracts can contact that smart contract and react based on that. You also have data arbitration. This is more useful for private use case, private blockchains that are not accessible to everyone. So let's say several companies want to, they have a lot of data and they want to correct the errors, like in financial sector, for instance. You can have data arbitration, and also decentralized business logic, storage, and execution. This is like something like the DAO a decentralized autonomous organization, like basically like a company on blockchain, etc. So now we will have a coding session. While I will open the coding environment, you can ask questions if you have some. Okay, can a contract written in a particular blockchain be executed on different blockchain platform? Not yet. People are working on protocols that can allow that, but you really need to. We don't have that kind of technology yet. Maybe it will be available in the future, but once you have a smart contract on the blockchain, well, on the Ethereum blockchain, it stays there, unless you have to manually create something that will contact that given contract and push it somewhere on the server, and the other blockchain can push it back, but it's cumbersome. But a contract needs to see a value relating an account. What do you mean by the value relating to an account? A contract can well, maybe I'll show you here. So I'm using here what's called Remix, which is a live Solidity programming environment. So you can write your Solidity code there and test it. It's good for small piece of code, and if you want to really learn. But if you want to use something at professional level, you need to use something else like Truffle, which is a framework. How to avoid bugs like the last one at parity? Well, you have to do a contract audition, contract testing, like in any software, except that once you write a contract on the blockchain, well, if you've made an error, if you put something like, okay, this contract has to give $5 or 5 Ether every time someone calls a given function without checking its identity, without having any permissioning, well, you cannot do anything about that. So the way to write, so now we will have a quick programming, smart contract programming session. So the first thing you need to specify is the compiler version of the smart contract. So this is done by Pragma Solidity. 0.4.0, we'll use this one. And then you declare the contract name, contract test contract. And that's it, you have your contract. So this is like the bare minimum code you need to actually create a contract. It's just a contract, you can deploy it, but there's nothing inside it. Which testnet is the best using? I personally prefer using test RPC. You can just Google it, test RPC. If you want to test your application, it's like you don't need to make it public on a testnet. It's better to use test RPC. It's very fast. It's basically a blockchain in memory, and yeah, it's very nice. You don't even need to care about Ether and stuff like that. You can just execute your logic and test it. Very useful. So I've talked before that we have certain components in the contract. So we have the getters, the setters, the constructor, and the event. We have already declared a contract name by simply declaring contract. Now we'll create a getter. So we'll create a variable, and Solidity is a statically typed language. That means that you have to put the variable type before the variable. So we'll create a unsigned integer, so any number that is not negative. Unit number, let's put it 42, and we have a variable inside the contract. So now if we deploy that contract on the blockchain, and here I will not deploy it on the real blockchain, however you can, if you have something like MetaMask, you can choose the injected Web3, and it will basically, and with MetaMask, you can basically choose the network that you will contact. You can choose the mainnet, you can choose the test network of your choice, or you can choose what is called JavaScript VM. It's basically like a test RPC, so it's a very fast blockchain in memory. It's very cool for debugging and testing. So now if I create this contract, so I deploy it in the virtual blockchain, I have a transaction that was just fired here, and I can see the details of that transaction, how much gas it costed, which from which account deployed it, and here I have 5 accounts to play this with, and you can see that this account is exactly this one. And you can also check the contract address, so you have different informations here. The question here is if I see any massive explosion of visual contract development tools. No, not really. I mean, the best tool I know is Truffle, definitely. But here is just good for like testing and learning. If you really want to create a production-ready solution, you need to use professional tools like professionals. It's not really professional, but it's the most closest to what we can get from a professional point of view. So here we have a variable, and we cannot get it. We cannot really consult it. We don't know what this variable is, because by default it's private. So I can put public here, and this will create a getter for me, but I don't really like that idea, because it creates like a function. But what if I want to put some condition in before actually returning that value? So that's why I will create a real getter. So you just create a function, you name it the way you want. I will name it getNumber. And function. And in order to tell Solidity that, hey, this is a getter, this is not a setter, because if I just write it like that, it will consider it as a setter. So it will fire a transaction. You fire a transaction only when you need to change a value, right? If I would need to change that, then I would need a transaction, then I would need a setter. But because I just want to consult that value, I need a getter. And the way to do it is simply put the keyword constant, and it will be considered as a getter. And I also need to say what the function will return, like in C++, C, those kind of languages. So return, and I will return a unsigned integer. So I need to specify the type. Now I can return number, and it returns here. Return number. That's it. So if I deploy it again, I will get a button. So it's a function you can call, and this button is blue because it's a getter. And if I deploy it without that, it will be red, and red are setters. So here I will deploy it again. And if I press on it, I will get the value. Does Truffle include some automated tests? Yeah, I mean it does. It does include Mocha and Chai, which are good, but not really automated testing. You need to code it by yourself. So we have a getter. I will just check how many time is left. Okay, we have a getter, and now if I want to change that value, I need to have a setter. So we'll create a setter, set number, and we won't return anything, but we will just provide a new argument. It has to be the same type, a new number. And I will just say number is equal new number. By doing that, when I will deploy the contract, here it's 42 bit, but if I want, I can put it 100, and the value will be changed. So every time I'm actually doing something here, it fires a transaction. It appends new. I mean, it creates a new transaction, which is appended in a new blockchain block. So everyone can see it, because here I have no permissions. So everyone can consult that value. So I updated to 50. Now it's 50. You can check the cost of the transaction here. Transaction costs simply because, sorry, not here. This one. Transaction cost simply because you call the contract. You pay at least 22,000 of gas, and execution cost, well, you pay for what has happened inside that. So if I put more code here, the execution cost will be bigger. Okay, now we have a getter and we have a setter, but everyone can just contact this contract if they know the contract address and just call that function and assign a new number. So it's not very secured. So the way to secure it is using permissions, and one of the functional quality of smart contracts, or the functional components that you can put is permissioning. So we will do that here. The idea behind that is to authorize only certain addresses to do something. So I can do it in a hard-coded way. So I know that this is my address, and I will just copy this address, and I will do something like if message.sender, and when someone is firing a transaction, if is firing a function on the blockchain, it provides an object called message, and to that object you attach several variables like sender, which is your address, value if you send some ether with your request. If you want to buy like tokens, you would send ether and you will get tokens in return. So I will check that the message sender is this address. If the message sender is this address, only then I can change the value of the contract, of the variable, sorry. And if not, it will just do nothing. I will just spend some gas and nothing will happen. So I will deploy it again. And now it's 42 because it is declared 42 in the beginning. So I change to 100. It is changed. So now if I take whatever, any other address, and I try to change it back to 50, well, now it stays 100. So I can click how much time I want. It won't do anything. So this is like basic permissioning. I have a question here. Can the contract retrieve some info from the blockchain? For instance, can I write a contract that says if an account X holds Y coins, do Z? I don't think you can do that. However, if you have that kind of question, you can just check the Solidity online documentation. So you can just Google it, and you will find the globally available variables. And normally it would be a variable bound to an account. So you would have something like address dot, and you can have transfer if you want to transfer a given amount of money to that address. And you have to check whether it's possible or not. But I don't think it's possible. I mean, not in my. I don't even think I had to use that functionality, so I need to check. But you can check in Solidity on the documentation. You will find if that's possible or not. So yeah, now we have a hard-coded address, but this is not very convenient. So what we will do is that we will use one of the code components that Solidity provides, and which is a constructor. And remember, a constructor is a function that is fired on the blockchain, on the smart contract creation. So we'll create one, and the way to create a constructor is just creating a function with the same name as the contract, so test contract. And then here we will just save the address of that has deployed the contract, because the one deploying the function will be kind of calling that constructor as well. So we can get the message.sender and register that in a variable, and later use that variable in a more programmatic way to do permissioning. So this variable needs to be of type address, and this is a specific Solidity type, and we'll name it creator. And when the constructor will be fired, we'll write creator is equal message.sender. And here, instead of putting a hard-coded address, we can put creator, and we'll have the same functionality. So now if I decide to deploy with another address, with the last one, I deploy it, and I can change the value. However, if I go to the first address and I try to change the value, it will not work. So this is a more flexible way of doing that. No, a smart contract cannot call external information. It cannot call REST API stuff unless no, it cannot do that. You can kind of trick the smart contract into doing that with services like Oracleize. You can Google it, Oracleize, and those guys actually allow the deployment of smart contracts that allow to push data on the blockchain, and you basically create oracles. And once you have an oracle, you can use the existing smart contract to contact that oracle and get some information. But it is a very expensive. You need to pay a lot of fee for that. It's not the best way to do it. If you need a lot of third-party data, then what's the point of making it decentralized, right? I mean, 99% of the projects do not really need to be decentralized. So in most cases, a private blockchain is a better solution. Okay, so we have a constructor. We have some permissioning. What can we do also? We can, how much time is left? Okay, we have 15 minutes. What we can do is to actually create an event, because let's say that an address executed that function, but it's okay if the creator calls that function. But what if we want to know any other person who called that function and who didn't manage to execute that logic? What if we want to log all the traffic that comes to your contract and calls that function? Well, we can do that very easily with events. So the way to do it is that you declare it like that, event. You give it a name. It's like a function, basically. Let's call it call status. Then you provide the arguments, and you can put whatever you want. Most of the time I use a string to have some information about what's happening. So most of the time I will declare it like that, string message. And here, what do I need to log? I need to log the address that has called that function, and a little message like unauthorized call, something like that. So you can put an address here, address. Yeah, I will do it, address. So basically, when I will call that event and I will provide a string and an address, it will log that in the blockchain. And it makes sense to use the events in the setters, but it makes no sense to use them in the getters, because since logs are something that are appended to the blockchain, you need a new transaction that will change the blockchain state. In the case of a getter, you don't produce a transaction. That means that your log will not be recorded on the blockchain. That's why you need to, it's very useful to use events in a setter like that. So here we will just call that, call status, and we'll provide the message like unauthorized, actually else, and then we will call the event. So if the message.sender is the creator, then good, we execute that. Else we want to log that we have received a unauthorized access. So call status unauthorized access, and the second argument is the address. And remember, the address you can get it with message.sender. Okay, I will just reload the page so I can get rid of all the information at the right, and I can deploy the contract. I have deployed it with the first address. So if I now change the number to 50, I have a transaction, everything is cool, and the value is changed. However, if I use another address and I change to and try to change the value to, let's say, 25, I will, if we check the details, I will be able to consult the log, and here it is, logs, and you see that you have a log called unauthorized access, and you receive the address. So the address is this one. Logs are useful because you can, when you're creating your dApp, and I will actually give a webinar on dApps specifically, and that means decentralized applications. A dApp can listen to all the logs that are fired on a certain contract and run some logic. So let's say that you create a contract where you need to make a payment to a with Ether. You need to buy tokens, but you create a website where it's all interactive, right? If you buy, let's say you create an account on the website, you specify your Ethereum address, and the website will be able to know if you bought tokens or not, because it will listen for the events on the smart contract. And once it detects that, okay, your address have actually bought tokens, the website can be updated. So this is a very nice pattern to actually have a historical trace of all the transactions that has been passed in a smart contract. Okay, I think that's all. I don't want to get very more specific on that. I think that it's a nice introduction of the capabilities of smart contracts. You can create variables. Those are like state variables, and it's like global scope, right? Those variables are available inside the functions, and those variables will basically be what will be written on the blockchain. So this data will be written on the blockchain, while the variables inside, like a message sender, and if I put some logic inside the functions, those will be local variables, and they will exist only in the EVM stack or memory. So once you call that function, everything is deleted. So if you want to change a value on the blockchain, you need to reference those variables in the global scope outside of the functions. Okay, I have a very interesting question about how do you actually interact with the smart contract. There are several ways, and I will talk more about that in the next webinar about dApps. So the way to interact with the blockchain is to you can use something like MetaMask. It is a very popular solution because it's basically a Chrome plugin that you, or Firefox even plugin, that you can use to store your account in the browser storage in a secure way, and then contact a remote node and basically interact with the blockchain directly from the website. And you don't even need to own a node. The most common way is that you need to own a node, like let's say an Ethereum node, and a Ethereum node is quite big. It's more than 100 gigabytes. So you need to download that. You need to sync that. But if you want to avoid that, there's a very nice solution called MetaMask. So you basically store your key store, your account in the browser, and the browser will connect to MetaMask servers. And I think they use Infura, and it's a secured way to actually contact the blockchain and pass transaction without the service knowing who you are. And yeah, you're welcome. So what was the issue with parity? The guy changed himself. It's a very difficult. It's a very difficult thing to explain. You can check technical explanations on that about that on YouTube. But basically, what happened is that, let's say that this is like the parity wallet. So I'll actually do something like a contract parity wallet. And this parity wallet was referencing, just for the sake of simplicity, I would use another contract. I would say permissioning library, something like that. So those are like two smart contracts, and this one will reference this one to make some calculations. And what happened is that this library was not the guy used a exploit in that library. The code was basically badly written, and he was able to actually delete that library. So that means that the parity wallet is not capable of referencing to that library because it's deleted. So if there was a check, like check if you have the permission to actually withdraw money, this check will also always be false. I mean, this check will always fail because the library does not exist. And that means that all the funds that were in the parity wallet, well, they are gone. I mean, they're not gone. They are there, but there's no way to actually get them out of that contract. Because once you have written a smart contract, it's there in the ledger. And if you haven't put any logic that allows to like change the smart contract logic itself, well, it's over. Unless you make a hard fork or you decide to like, the hard fork is the only solution for that. But you need to reach consensus, and sometimes things can go pretty bad, like it happened with Ethereum, with the DAO that was hacked, and more than 200 millions were locked in the DAO, and people decided to do a hard fork. Yeah, usually when you are trying to develop a smart contract or just test it, just try to use test RPC. It's very, very useful. And you can find it here. It's a JavaScript library that allows you to have a virtual blockchain in your memory, and you can stop it, you can fire it. You don't need to download anything more than that. And it's once you have tested it on test RPC, you can test it on a real blockchain. You download I don't know, Get or Parity. You create one node, you try there, then you try on a network like Ringb. And I saw a question about the problem to connecting to a real test RPC. Well, you can do it that way. Look, you download MetaMask, so we will have a plugin here, and then you go to Remix Solidity Online Compiler, and then you select Injected Web3. Okay, you select Injected Web3, so it says that it needs MetaMask. It's not happy. Then on MetaMask, you select. Once you have created your MetaMask account, you select the test RPC, and you write a contract and you deploy it. And when you deploy it, it will be directly deployed on the test RPC. Not on the test RPC, on Ringb or something like that. Every operation that changes the state of the contract costs gas. And other great tools, no. I mean, Truffle is the only one that is useful. There's also Zeppelin if you want to reuse contracts. They have audited smart contracts, but other than that, yeah. Thank you a lot for your time, and I hope that it was useful.